let's connect n8n to Pinecone. In this video, I'll show you how to upload your documents into Pinecone, create embeddings with OpenAI, and then query them with a real AI agent. By the end, you'll have your own private knowledge base fully powered by n8n. So why do we want to set up Pinecone in the first place? Well, most businesses right now are experimenting with AI agents, but here's the problem. They're only as smart as their prompts. You can ask a model questions, but it has no memory of your internal data, your documents, your policies, or your customer knowledge. What that means is it's going to give you generic answers, not insights from your company's actual data. So to fix that, we need to set up Retrieval-Augmented Generation, or RAG, a setup where your data is stored in a vector database like Pinecone, so that your AI agent can search your knowledge base before responding. Think of it like giving your chatbot instant access to every document your business has, but with natural language search instead of keywords. That's what we're building today, a real-world RAG pipeline that connects to n8n, OpenAI, and Pinecone to give your AI agent the same context your team has. So let's get into it. Let's do a quick demo so you can see how this actually works. I'll upload a document called KnowledgeBase Frequently Asked Questions in our Google Drive folder. Then I'll go to n8n, and now let's watch our workflow run. n8n picks up the file, extracts the text with the default data loader, creates OpenAI embeddings, and sends them straight into Pinecone. In the Pinecone dashboard, you can already see the vector count. That means our document is officially stored and searchable. Now let's ask our AI agent a question. What's our shipping policy? It sends the question through the embedding model, searches Pinecone for the closest match, and replies with the exact policy text from the document. Now that's a full RAG pipeline in action, no code, no guesswork, and your data stays completely under your control. So let's go and build this. Before you begin working on the n8n workflow, make sure you have a Google Drive folder set up. I've called mine data, and I've added my knowledge base document here that's going to be ingested into Pinecone. Next, let's set up our Pinecone index. This is where all of our document embeddings will live. In your Pinecone dashboard, click on the Create Index. For name, type data. That'll be the index n8n connects to later. Under configuration, choose Text Embedding 3 Small. It's the most cost-effective OpenAI model for generating embeddings and works perfectly for our RAG setup. Make sure the dimension is set to 1536. This is pretty important as it matches the embedding size of the OpenAI model that we're going to use. Now just click Create Index. I've already done this, and you'll see your index data once it has been successfully created. Start by setting up our data source, Google Drive. Open a new workflow in n8n and drop in a manual trigger node. This is how we'll test everything live as we build. Next, add a Google Drive node. Search files and folders. This node lets n8n scan an entire folder of documents. That's what will turn into the embeddings later. Then connect the credentials to your Google Drive account. Set up your credentials if you haven't done so, otherwise you'll just need to connect via OAuth 2. Make sure to set the operation to search and the search method to search file and folder name. You'll want to leave the search query as blank. Set return all to true. And then for your filter, choose the folder that your files are stored in your Google Drive folder. So for me, my files are stored in data. So once it's linked, hit the execute step node. You should see a list of all your files, names, IDs, and MIME types. That's your Google Drive connection set up and returning the data perfectly. Now that n8n can see our folder, we need to download each file so we can work with the actual content. Add another Google Drive node, and this time set the operation to download. In the file ID, type json.id. That little expression tells n8n to grab the ID from the previous node for each file it finds. When you run this node, it takes every file from the search results and downloads the binary data. Basically, the raw file content we need to feed into your AI pipeline. Let's hit execute step. You'll see the output change from text to a binary object with fields like data, MIME type, and file name. This means n8n is now pulling the actual documents from the drive, not just listing them. That's exactly what we need. Our files are now ready to be processed into text and embeddings. Now, if we had more than one file in the folder, we need to make sure we process our files safely one at a time. add a loop over items node and connect it directly after your download files node. This node is like a traffic controller. Instead of sending every file through the workflow at once, it sends them through one by one, all in small batches. This is important because OpenAI and Pinecone both have rate limits. So if you try to upload hundreds of files at once, the workflow could fail or even slow down. The default batch size is set to 1, which works perfectly here because it will download a file, process it, and then loop to the next one automatically. For now, think of it as your workflow's rhythm, steady, consistent, and safe. Now that you're looping through each file, it's time to extract the readable text inside. Add a Pinecone vector store and a default data loader node, and connect it into your loop. This node takes a file like a PDF or a document and automatically converts it into text that your AI agent can understand. So to set up the Pinecone vector store, you'll need to add your credentials. Now to do this, we'll need to go into Pinecone and create an API key. So once you create the API key, just give it a name and then go back into n8n. Click on new credential here and paste the API key right there. Set the operation to insert documents so it knows we're uploading data, not searching yet. For the index, pick your Pinecone index name. I'm using data. The embedding batch size controls how many text chunks get processed at once. 1000 is a solid default. Then under options, set the namespace to KnowledgeBase or whatever you've called it. Think of that like a folder inside your index. It keeps the project's data separate from other projects. Once this is set up, every document you processed will be turned into an embedding and stored neatly inside of Pinecone, ready for your AI agent to search. Next, make sure that you add the OpenAI embeddings, and for the model, just choose text embedding 3 small. Now, when I click execute step, n8n takes all of the chunks from our document, in this case the KnowledgeBase frequently asked file, and starts sending them to Pinecone. Each chunk is first converted into embedding using OpenAI, which turns the text into numeric vectors that represent meaning. Then those vectors are inserted into Pinecone inside our data index and KnowledgeBase namespace. On the right, the page content has been uploaded into Pinecone. Real text from the document has been chunked and tagged with metadata like file type and source. Behind the scenes, Pinecone is storing each of these chunks as searchable vectors. If we check our Pinecone dashboard now, we can see there are 4 new rows that have been added. That means our data is officially live and ready to be queried by an AI agent. This is the key moment where your document becomes searchable by meaning, not just keywords. If this build's helping you connect the dots, hit subscribe right now. I drop new n8n automation builds every week, so subscribing means you'll never miss a workflow you can copy straight into your vault. Alright, let's finish strong. Now that our documents are in Pinecone, let's make them searchable with a chat interface. Add a chat trigger node. This node listens for messages you send to the workflow so you can ask questions in plain English. Keep the defaults. With the trigger in place, we can now wire an AI agent that knows how to use Pinecone as its memory. Next, add an AI agent node. In the system message, type "You are a helpful assistant who has access to the Pinecone tool to answer the user's questions." This tells the AI agent it can use external tools, not just rely on its own knowledge. Think of the AI agent as an orchestrator. It uses a language model to interpret the user's question, then queries Pinecone to find the relevant information from your knowledge base before replying. Leave all the other settings as their defaults for now. We'll connect the language model, memory, and vector store tools in the next steps. Our AI agent needs a language model to understand questions and craft responses. So add an OpenAI chat model node and connect it to the AI agent as the language model. Select GPT 4.1 mini, it's fast and affordable, perfect for this sort of back and forth Q&A. Next, let's give our AI agent a short-term memory so it remembers what was just said. Add a simple memory node and connect it to the AI agent. This keeps a rolling window of the last 5 messages, so follow-up questions like "and what about pricing" still make sense without repeating yourself. You can leave the defaults or set the window size that fits your use case. Now, let's give our AI agent the ability to search for Pinecone before answering questions. Add the tool Answer Questions with a Vector Store. Connect it to the AI agent. So this tool is the bridge between your natural language and the stored embeddings. When a user asks the question, it runs a semantic search, pulls the top matches, and returns the relevant chunks to the AI agent. Set the description of the data to use this tool to answer the user's questions. We'll point it to our Pinecone index next and add the embedding model it should use for the queries. So next, add a Pinecone vector store node and place it next to the answer questions with a vector store. Connect it with your Pinecone credentials and then set the operation to retrieve documents as a vector store for the chain/tool. For the index, choose data. That's the index we created earlier. And for namespace, type KnowledgeBase so we search for the same bucket we used during the upload. Next, we'll want to add the embeddings model. So again, select text embedding 3 small and add the OpenAI chat model back to our answer questions with a vector store. You can just use GPT 4.1 mini again. Now for the best part, let's see it in action. In the chat window, type "What's our shipping policy?" and then click send. Watch what happens behind the scenes. n8n sends your questions to OpenAI's embeddings and turns it into a vector and searches your Pinecone index for the most relevant chunks. Then Pinecone returns the top matches. And just like that, your AI is now answering real questions using your company's own data. No hallucinations, no manual lookups, and completely automated. That's a true RAG pipeline built entirely inside n8n. And that's it. A production-ready RAG pipeline that you can point at any company policies, frequently asked questions, or internal content that your team needs instant answers from. You can grab both JSON templates inside my automation vault at www.kristorrington.com. If you found this build helpful, make sure to hit subscribe. I drop new n8n automation builds every week. I'm Kris, and thanks for watching. I'll see you in the next one. Have a great day.